Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2018 or 2018 paper 1 higher tier in the combined science physics paper. Question number 3 is on the particle model of matter. Figure 5 shows a diver. The diver is using a canister of compressed air so that he can breathe underwater. Question 3.1. Which two statements describe the movement of the air particles in the canister? Tick 2 boxes. So you're expected to tick 2 boxes, right, for 2 marks. They vibrate about a fixed position. That's for solids only. That happens in solids only. So we are not going to tick that box. They move in random directions. Yes, they do. That's for gases and in liquids. So gases and in liquids it happens. The motion of all the particles is predictable, but if it's random, you cannot actually predict it. They move with a range of different speeds. Yes, they do. That's for gas and for liquids as well. They move in circular paths. No, they don't. They move in random directions. So those are the 2 points. The next question, 3.2. The temperature of the air inside the canister increases. What happens to the movement of the air particles? Now, if the temperature increases, then the air particles would gain more energy. If they gain more energy, then they would move faster. So the answer is the mean speed, or you could say the kinetic energy of the particles would increase. So you have to refer to the word kinetic energy or speed here, and you need to say that it would increase. Question 3.3. It could be dangerous if the temperature of the air inside the canister increased by a large amount. Explain why for 2 marks. Now, if the temperature increased by a large amount, then the kinetic energy inside would increase. The particles would be hitting the canister walls with more force, and that increases the pressure. Right? If the pressure builds up, eventually that can actually explode. This is the reason why you wouldn't want to throw deodorant cans, whether empty or not, into open flames like a bonfire. That's really dangerous. So the pressure increases, so it could explode. 1 mark for each of those statements. A canister of air was tested to find out how the pressure changed when it was used by a diver. The air was allowed to escape from the canister. The pressure of the air in the canister was recorded every 5 minutes for 80 minutes. So if the air is actually escaping from the canister, you would expect the pressure to slowly drop every 5 minutes till it reaches up to what would be the normal pressure equivalent to the atmospheric pressure here, right? Estimate the atmospheric pressure. They are asking you to estimate the atmospheric pressure, which is basically at this point right at the bottom. After 60 minutes, it's actually the same. The pressure is actually maintained, so there's no air coming out, right? And for 0.5 megapascals, there's 5 boxes in between. So each box is 0.1 megapascal. So the atmospheric pressure is 0.1 megapascal. Question 3.5. Divers can safely stay underwater until the pressure of the air in the canister has reduced to 25% of its original value. Determine the maximum time the diver can safely stay underwater. So the diver is actually safe up to 25% of the original value. So we need to find the original value from the graph and find out how much 25% of that is. So the original pressure is 2.25 megapascals, right? So 2.25 megapascal, if I divide that by 100, I would find out what 1% is, and then multiply it by 25 to give me the value of 25%, which is, let's do that in the calculator, 2.25 divided by 100 and multiply that by 25. That gives me 9/16, which is 0.5625. So in round it off to 2 decimal place, 0.56 megapascals. PA. That should be capital M, right? So that, because that's capital M for mega, not lowercase m. And 0.56 megapascals here. So 0.5, and this is 0.6. So 0.56 should be in between here. Let me increase the size of that so you can see that clearly. And that makes it better. So that will be 0.6 there. So it should be in between. So it should be about there, right? And that's about somewhere here. So that's 5 boxes for 10 minutes. So each is 2 minutes. So it's a 20, 22, 24, 26, about 27 minutes. We bring it back to focus. There you go. So that's 27 minutes from the graph. Question 3.6. What happens to the volume of the air when it is released from the canister? Now, when it's inside the canister, it's under pressure, so the volume is actually lower. But when it is released from the canister, it should increase, or the air should actually expand. So the volume of the air increases for 1 mark. That brings us to the end of question number 3. I will see you in question number 4. Thank you.